Oh, we're being recorded.
Yeah, this is going to be recorded and
Hmm.
it will be on the Simulation Australasia YouTube channel.
Hmm.
Uh, so first of all, we acknowledge the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respects to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander people today. Um, and with that, let me hand over to Thomas. Thomas, yes, the floor is yours. Uh, can do an introduction about yourself and also start your presentation.
Okay, I'll just share my screen, hoping that everyone can see it.
Yes.
Um, yes, so for those who just joined, well, thanks for having me, first of all. This is my first SIMCAFE. Been working for this company called SIDAC originally, then Octal SIDAC as we merged with a French company. I'll talk about the company for just after, but I'm the head of engineering here in Australia, looking after engineers who are software developers, modelers, so people with more of a background in electromechanical kind of engineering, and also production engineers, people who build the thing. So what do we do? Um, well, maybe first of all, what are we going to talk about today? It's this new product called SIMALYTICS. That's a simulator that is it's designed to help freight operator enhance and optimize their rail assets, their operational needs, etc., etc. I'll get into the features soon. Um, just giving you a little background as to why we got into making this simulator product, giving you an overview of what it's made of, how it works, the sort of flows that we have designed for our customers, key features, and delving just a tiny bit deeper into the train model itself, because that's really the centerpiece of this simulation product. And then the sort of features that we would like to be developing in the future as part of our roadmap. So first of all, who are we? Well, as Udi said, I joined this company 7 years ago, almost eight now. Coming from Belgium, just, um, seeing what Australia had as opportunities for young engineers like me. And then over the years, we merged with this French company called Octal that essentially does the same thing as we had been doing. And it was part of a bigger group called Sogeclair. We've been the core of our market of our business is really to deliver simulators, a bit like flight sims, but for the rail and road industry. So anything that's heavy and that has some safety aspect and requires some training on computers before you jump into the real machine. Um, so we've delivered to customers like BHP, Transport for New South Wales, Transport for Melbourne, but also SATA, TAFE for truck simulators, and also for customers all over the world. We've got an office in India and in France, in the south of France, Toulouse as well. So over the years, we developed quite background knowledge into railway systems and have been able to refine our models to simulate more and more accurate and refined dynamics of the train, and this has led to us to get into this not so much training simulator, but simulator more designed for engineering. purposes. We'll get into that. So what did we observe in the market is that freight operators, or the for example, the big mining companies here in Australia, but also in the United States and South America, Canada, they are, well, first of all, they have similar systems. They have trains that are all standardized by American Association of Railroads, and they're constantly looking for ways to improve their operations, right? Time is money. The sort of goods that they transport with their trains are very valuable, and the more they can ship, the more returns they make. So that's one thing. They also want to be able to reduce the amount of wear that can happen in their system. They're subject to pretty harsh condition, and as you may know, these trains are huge, many kilometers long, carrying hundreds and thousands of tons of goods. What is especially focus for them is coupler breakage issues with the coupling between the different cars. They want to be able to assess whether they require upgrading their equipment, change the track configuration in order to well deliver their goods in the fastest way possible and the safest way possible. So customer lists that we identified in a different part of the world that are all standardized according to American Association of Railroads. So this has led us to design this product to kind of which we call SIMALYTICS, for simulation analytics, which is really a tool designed to help operators optimize their processes. How they do this? Well, they want to be able to simulate scenarios. What if I try a different kind of locomotive? What if I use a second power point in the middle of my train? So not just having locomotives at the front of the train, but also in the middle or at the back of the train. And they also want to be able to rerun real life scenarios through simulation and have a finer view as to what actually happened in the train. Did I damage my coupler? Did I get an did my driver get an emergency braking that might have damaged my train? So we ended up listing features that would be useful for this sort of analysis. And we came up with, well, a model that we had already built over the years for training simulation, training purpose, that we made as parametric as possible for operators to try different systems, a track builder to allow them to draw and simulate their railway track, a rule build, what we call a rule builder, which is essentially designed for replicating driving instructions, because they usually have a list of instructions as to how to drive their train along the track. Event recorder playback, which allows you to replay something that extract data from your real train and replay them in simulation. And also all the sort of displays that you need to observe what the dynamics outputs of your train is in simulation. So just delving a little bit deeper into the different workflows. So we've got the workflow that was designed for simulation of what if scenarios. It's essentially building your track, building your train with the type of parameters that you have on the real system. running the analysis and building the train that you want to simulate and running the simulation. Whereas if you want to investigate a real life run, then you would be importing data from what is called event recorder, which is essentially a black box located on the real train that records a bunch of parameters: how the driver drove the train, did they get an emergency, what the pressure in the brake pipe was, for example, and so on and so on. And we rerun that as part of the simulation in order to provide our customers and users to analyze what exactly has happened during that run with the level of fidelity that our dynamic simulators provide. What does that look like in practice? So there was a big effort in trying to identify key parameters in the train system, how to be able to configure your system, your locomotives and wagons as close as possible to the system that you actually own as an operator. So this was identifying what sort of brake valves were used on this sort of trains, because again, they're specified as per American standards. Same for drive gear couplers, being able to define the amount of slack that you may experience in your couplers, because that's really important in the calculation of the forces that are being experienced in those couplers. Fuel capacity of the wagon, and so on and so on. So I hope this is sort of clear for now. And I'll take questions at the end of the session. We'll have a Q&A discussion. But don't hesitate to, I think I've seen a few comments going around. Don't hesitate to pop comments as we go, and we'll get through them at the end of the presentation. So what's the train model, the freight train model, looking like? Well, it's essentially designed and implemented with MATLAB Simulink. It's a functional model based on the different main subsystems that are in play within the train to make it move, essentially. So things like traction system, braking system, power generation, which are typically for this type of big heavy trains, diesel engine that are huge. The electrical control system. So we essentially get the configuration that we just saw in the previous slide, stored in a database that we do a bit of processing on that to just adjust to our own internal dynamic parameters. They're passed on those different subsystems masks in Simulink. I'm sure you probably are all familiar with MATLAB Simulink. If your background is in simulation, we get the controls from the driver or from those rules that we described earlier. Do a bunch of processing on those input as well. All of this needs to be run at real time or faster, because well, one, if you want to drive it, you want to drive it in real time, but you also want to be able to run those simulation automatically as fast as possible to get your results and do your analysis. Output processing, so that's essentially like providing all of the data, the meaningful engineering data that you need to perform your dynamics analysis on your system, as output, either logged into what you could read as spreadsheets, or to display on graphs that can be observed in the simulator directly. I'll get into that in a minute. So you build your train. The other very important part is to be able to build your track as well. So we've got another tool for that that's embedded as a plugin to this simulator that we are actually in the process of refactoring. As you see, the interface is a bit old, to put it this way. That essentially allows you to define your track, the elevation of it, different slopes, curvature, etc., etc. And also a tool that was really important in the industry for a while was the New York Air Brake TDS simulators. That has since it's a company that we've essentially been refurbishing a bunch of simulators for them, and was sold to many freight operators in the United States because NIAB, New York Air Brakes, is a American company. So it was important for us to be able to inject that data straight away into the track builders in order to automatically generate their track based on that if they already had created their track for those simulators. So we had some kind of like back compatibility for these old simulators. Went too fast. Rule editor. So as I mentioned, operators, they often come, well, one thing that is quite common to old school operation is just to have a good old notebook into your train as a driver that essentially tells you how to best operate your train. So if it's fully loaded or empty, it's going to have instructions such as once you pass that crest at milepost X, start applying brakes in notch, who knows, 6 or whatever, to start slowing down the train because obviously like these trains are massive and heavy, and if you start taking down the slope too fast, well, they're basically unstoppable. So this sort of instruction, driving instruction, really provide you with clear view as to how you're supposed to be driving your train as an experienced or new driver. We wanted to be able to vary the environmental conditions as well, change the track adhesion based on whether we're simulating a wheel track interface in Canada, for example, where it's on a freezing day, or if it's on a very hot day here in the Pilbara region, for example. Being able to apply some factors to your braking and traction capability based on, let's say, the age of your train. If it's an old train, it might not perform as datasheet specification, and to parameterize some particular system like distributed power electronic control of the pneumatics. Could give you a whole course on that, but essentially the systems that allow you to control your train more accurately and remotely, systems that have shown up in the more recent years. Data logging, so I've touched on that. It's essentially saying, well, this is the place where you instrument your simulated train. You sort of set a bunch of sensors or simulated sensor on your train, and you say, I want to record the vehicle accelerations. I want to record the coupler forces, buff and draft on these and those vehicles, where be them locomotives or wagons. And you can also provide some aggregator because you want to just focus on what is the absolute peak value that the coupler force have reached, and may trigger breakage at that particular point in the train. Adjustable logging rate as well as to how fast you want those sensors to be behaving, and all of this gets outputted into essentially a CSV file, which is a big that can be opened with Excel, and you see things like where where those parameters were recorded, at what time, what location, etc., etc. Hope all of this makes sense. The different type of sessions, simulated sessions that you are able to simulate with the simulator, where standard session is essentially a live session or a session that you can drive your train manually or using the driving instructions that we talked about, where you replicate your driver handling book, and the train is going to be automatically driven following those rules. Replay sessions, essentially just replaying a session that has already happened, and then the very important event recorder session. So that's, in this case, it's not, the train is not driven as per your manual instructions, be them entered as part of the rule editor or just manually during the session, but it's all extracted from a file of data recorded on the train itself through those event recorder, these black box that I was talking about earlier. So essentially you load up all of your data, and the train is going to be rerun in the same fashion as it was driven on that very day. Live and batch simulation, why it was important for us to do batch simulation as well, especially for the event recorder session, where you get a bunch of records of what has been happening on your train, say over the course of a week. You might be wanting to rerun that in simulation over the weekend or overnight to see what has happened. And this feature allows you to essentially create what you could consider as a playlist of these different sessions that we just talked about, and say run this overnight or on that day, and I will come back on Monday and analyze all of the information that came out of it, in order for me to do what we said, optimize my procedures, give feedback to my drivers, see if I want to do this or that change in my operational procedures. The driving displays that I was, or engineering display that I was talking about earlier, essentially, well, a reproduction of what a driver would typically see on their computer screens in the train, that allows you to drive the train in simulation, see how fast you're going, what the pressure in your reservoirs are, if you're cut in or cut out to the brake pads, things like that. And then on the other side, we've got the engineering display that essentially, well, use all of that data that we have instrumented on our train, all of the simulation outputs, and plots them in things that make sense, either along the length of the train. So we've got the down the train plots, we call them, that shows you the value for the different parameters for each vehicle, or you can record them over time with some special aggregators, peak, max value, etc. So where do we want to take this product in the future? Well, we still have we're still probing the market and getting information from our different customers. There's obviously a big focus on transitioning the industry towards newer technology, cleaner technologies. I was talking about diesel generators earlier, where we see a shift starting to happen, at least at the research level, to try and look for cleaner source of energy generation. Things like fuel cell vehicles or battery powered vehicles, essentially a big wagon, which is a huge battery powering an electric locomotive. We would like to look at features and functionalities that allow you to finely tune your speed control in areas where, for example, you'd be loading your train and you would have a change in the loading profile of your train. Provide tools, as you see, so the engineering, live engineering displays are well, they're for the live session to see what's happening during your train, and then you get the spreadsheet. We would like to be able to also provide tools that allow you to reload all of the data that was extracted from the train and being able to do analysis straight in the simulators, instead of just do your rule edition rules scripting before the session, also being able to finely tune these things during the session. So these are all features that we would like to be implementing in the future for this product. And that's probably our presentation for Simalytics.
Thank you, Thomas. I understood everything because I'm in the same industry,
Uh-oh.
same company as you. But I'm just gonna open the floor to everyone who has any questions on the technology, on the simulation aspect, on the industry. Yeah, happy to pitch in and answer, and also provide Thomas the floor to answer. I did have one. Comment. Just to expand on what Thomas mentioned. This is to optimize the driving strategy so that we increase the revenue throughput from the mine to dumper to port. So to increase that revenue throughput, that's why all the mining companies and the freight rail companies look at optimizing their rail assets, optimize their operations. Driving strategy for the freight rail assets is important because it's you're pulling a lot of tonnage on a rail or on the rail asset and on the equipment itself. So there are a couple of elements on the entire work stream, which is the vehicle itself, the train, the locomotive, and the wagons. Then you've got the rail, which is the wheel rail interface, and then you've got the operation of it, the total operation of it, and then you've got the driving strategy. Everything has to perform at utmost optimization for them to have the maximum revenue and the maximum throughput for their mining or freight rail operation to have a massive benefit. So I was in a session yesterday at Heavy Haul Rail in Perth, where there were three sessions which were interlinked. One from Monash IRT, the other one was from Loram Technologies, and the other one was from Rio Tinto. So it was interconnecting the digital twin and optimization model, where you need a digital twin for the vehicle itself to manage coupler forces, in-train forces, and the wheel train interface forces to make sure that the damages for
for
internal
internal
um, for the internal equipment is managed, prevented, and addressed in a timely manner. And then there is the whole operation. You need to use at least a bit of AI models. Rio Tinto has done a good job in the last 6 months to adopt AI models to optimize their operation to maximize the revenue throughput. And then the rail interface itself, the rail interface gets damaged when you get more tonnage over the rail. So you need to grind it properly, and you need to make sure that you reduce the damages on the rail. So you need to have kind of an optimization life cycle where you don't let it fail. If you let it fail, then that means you need to do a massive infrastructure enablement. So before failing, you need to do preventive maintenance and use optimization levels to make sure that the rail interface is functional in the most optimum manner. And then on top of that comes Simalytics, which is the driving strategy. All those parameters can still function properly, but if the driver does not drive the train in an optimum manner, then everything else fails. So that's where Simalytics comes into being, where the driving strategy needs to be optimized. Elizabeth, any questions?
We've got a question from Catherine. When
Oh,
a driver is operating via the software, is she actually seeing a visual of the rail line? No, there's no simulation of vision in this case. Do I have an actual vision? So this is essentially what they're going to see is where they are on the track, and they can operate this. At least that's for the default software. For our training products, we definitely have vision simulation as well. So you will have visuals like these ones of well, where you are on the track and what's happening. This is actually a picture of a training simulator that we have where you see there's a vision screen. How do they make the connection with the act of driving? So they have feedbacks of where the train is located. They have visuals of like what speed they're going, exactly what's going on. But the idea with these simulators is really mostly not so much for live driving of the train. It's mostly for simulation of batches. You want to be able to try different driving strategies that you build with your rule editor, and simulate many of those in order to see which one is going to give you the best output. Does that make sense?
Yeah, can you hear me? Sorry, my computer is playing up terribly, so I've had to switch to the phone. So thanks, that makes a lot of sense. And I guess that what was happening for me was that I was thinking about, that sense of when you're driving, a car or anything else, you've got a physical sense of movement, of actually doing the actions. But if this isn't primarily for that driver training, but more for analysis, that helps me understand where it fits. So
Yeah,
if
it's
yeah,
the product is very much tailored for analysis. It's more of an engineering tool than a driving tool.
right.
But we do offer this opportunity, to take over at any time and do manual driving, manual correction to how what your driving strategy might be.
So how do the drivers respond to this? What comments do you get back from the train drivers?
Train drivers, it's not they're not necessarily using the
So
simulator
they're
directly.
not
It's more
actually
the
doing.
operational
So
level.
so who are the people who are sort of those people sitting in front of the screens you showed? What's their role in the business?
Well, they might be the engineering team of, say,
yeah,
this or that
yeah,
operation company that wants
Okay.
to have an idea of, let's say, what the brake capability, the braking distances might be on this or that section of the train. For example, that was a use case that we had with BHP. They wanted to be able to say at any point of the track, we want to be able to know exactly what our braking distances are going to be so that we can inform our drivers, develop strategies that will be as safe as possible so that they will be able to stop wherever they are in the right amount of distance. It can be someone who's looking at having a better comprehension of um, who sorry, not who how much damage, how much force is being recorded within the couplers, and more like simulated in this case, in order to inform their maintenance scheduling. So it's more at the operational level than at the nitty-gritty of the driving. It's the team that does all the engineering analysis that informs the driving and the maintenance scheduling, and also the team. For example, we've had teams in South America that have used the product to say, well, the track team, the track building team is looking at doing reworking this section and making it go around this curve instead of that curve, and they want to know, well, our trains are huge. What happens if they're going to take that curve? Is it going to stress the train too much? Is it going to lead to more risk for our couplers or for our drivers themselves? Um, or also power efficiency, for example, like fuel efficiency, how to drive the train in such a way that's going to improve your consumption of fuel. This is the sort of like analysis and studies, engineering studies that our customer would like to be able to do with such a tool. Not so much driving and seeing live what it looks like to be
Okay.
driving. Does that make
Yeah.
sense?
Yeah, it
So
makes sense to me.
yeah,
Yeah.
just
I'm
to expand
hearing
on that.
it,
Sorry,
it,
go ahead.
it's profit maximization, it's asset maintenance,
Mhm.
and also safety is what I'm hearing is the key.
Exactly. Yeah.
Yeah. And also
Engineering studies.
driving
Yeah.
strategy. So there are a couple of simulators that we do. We do freight train driver training simulators. That's one of the images that you saw. That's separate to this Simalytics tool. So the image which you see in the middle and the image which you see on the left is the driver training simulation aspect. That is not Simalytics. That is the driver training aspect. But Simalytics is more of a engineering analysis to set up driving strategies and to also analyze, all right, if my driving strategies is such and such, what is the impact on the couplers, what is the impact on the wheels, what is the impact if I brake too early, where would I stop? If I go at this speed and if I start braking, where would I stop? And that kind of informs the track design, that informs the engineering decisions, that informs the maintenance scheduling, which this tool actually provides that analysis. Yeah.
And these are tailored to different fleets.
So the whole idea behind the parameterization of the model itself is precisely to tailor to your own fleet. So you will be able to, I think by default, we provide presets of, I can't tell you from the top of my, at least 3 or 4 locomotives and maybe 7 or 8 different type of wagons, but you can essentially build however many you want, based with the parameters that are described well here. But there's a bit of more of an extensive list. Does that make sense? It's to tailor to your own fleet.
Yeah. All
So
right.
Vinod had some questions, but I'm not sure if he's still on the line because he had to go away to make a call. But it struck me that his questions were kind of more along the line of
Yeah.
what I was thinking, that this is it is an instruction, whereas it's actually what Catherine said, benefit, cost benefit analysis and so on.
Yeah, so
we know
it's definitely not a gaming simulation. There's not really a competition aspect, and there's no catering for what we would call integrated session, where you would have multiple users driving trained at the same time. We provide this sort of functionality on our driving simulation, but not for this. As to how long does the typical simulation last, that's really up to the user. At the end of the day, we don't really have limitations on the length of simulation, but if you just want to simulate a braking distance for a certain speed at a certain location of your track, that might just be a couple of minutes, right, to brake and stop your train. But if you want to rerun the whole driving from port A to port B, and that in real life takes maybe a whole day of driving, well, you can do that too, and probably you would want to use the accelerated simulation speed, so in order to fast forward a bit and run the simulation as fast as your computer can go.
But when you do that, does it still pick up like the nuances of as if it would be running at real time? What's the difference between running at fast forward and real time for the clients?
The simulation itself of the dynamics itself is run at 1 kilohertz. So as long you can't go faster than a millisecond per second.
Right. Yeah.
But the logging provided is 200 milliseconds, so you will get, that's the fastest you can log information from your train parameters to the file. So it's you don't lose data.
You don't lose data. That's what I was looking at. You don't lose the data. It just comes in very fast, but then you can unwind it, analyze it in
That's correct. Yeah.
slow motion, so to speak.
Yeah.
Okay. And thank you. That's sort of given me a much better idea of how the software works. And I'm sorry, I can't see anyone because my computer's decided to play up. I don't know whether anybody else has got any questions.
I'm going through the chat history, but that's all. Vinod's questions were answered pretty much during when we discussed about how the two different simulation aspects are. The driver training aspect is separate to the engineering analysis. So I think those questions were answered, and Vinod will look through the video when he gets the chance. We do have Maria Nicholas with us. Hi, Maria.
Hi, Dee.
Hey. So just to introduce to everyone, Maria will be the speaker for our April SIMCAFE. Yeah. So
Nice to meet you.
Hoping to see
Nice
you
to meet everyone.
in April, Maria. Maria will be talking about immersive technologies in early education. I hope I got that right, Maria.
Yes, in higher ed.
Yes. Yeah.
So
Brilliant.
early education programs in higher ed, is that, did I get that right?
That's right, Catherine. Yeah.
Yeah.
Oh no, it's Elizabeth, isn't it?
Yeah,
Elizabeth.
sorry.
Yes.
I have technical problems overwhelmingly. So yes, I look like Catherine, but I'm actually Elizabeth.
Yes, there's not two Catherines.
yes. Sorry about that.
Well, I think we can close the session for today. Thomas, thank you very much for your time and putting this presentation together for the SIMCAFE. Thank you everyone who joined, and
Yeah,
looking
thanks,
forward.
Thomas. That gives me. I just wanted to say, Eddie, that gives me a very different perspective on another form of simulation. And if you're having a look, I'm putting stuff up on LinkedIn about what is simulation. So this is a whole different run for me of what is
And
simulation.
yeah, and also in our call that day, Elizabeth, with Duncan, I did mention that we need to bring this forward for the Sim Congress, because in the
Yes,
Sim Congress
please.
we've never had a transportation approach, which is why I'm trying to advocate and bring in a transportation abstract
I'm
and
right there
paper.
with you.
Yeah.
For sure.
So this will be one of the this will be one of the abstracts that Duncan has already
Good.
submitted.
Well, thank you, both Thomas Anudi and Duncan in absentia, because I think this is another whole area that CMOS is really building awareness of for people in simulation generally. So thank you for contributing, Thomas.
Thank you for having me.
Thanks a lot. Then we will see you, Maria, in April.
And thanks, Maria. Looking forward to it.
Thank
you
you.
very
See
much.
you all then.
See you
See you
then.
then.
Bye
Thanks
bye.
for
Good
listening.
afternoon.